for day one. We regret that we are running a little behind the schedule, and we are thankful to the speaker, Dr. S.M. Yadav, sir, who has adjusted to the timing because of our limitations. So I'll just give the brief introduction of sir. Dr. S.M. Yadav, sir, is professor in Civil Engineering Department of SVNIT Surat, and he has an experience of more than 30 years in teaching. He has guided more than 50 MTech dissertations. He has more than 200 research papers to his name in various international national journals of repute and conferences. He has done number of research projects under DST, and number of expert lectures sir has given in different institute of Gujarat as well as India. Sir is editor and reviewer to a number of journals like ISH, KSC, Journal of Flood Risk Management. Sir is active member of number of professional societies. It's a long list of achievements sir has got. Sir has been selected for a number of a number of trainings by the MHRT. He has been given the fellowship by the Australian government 2 times to visit the tree and present. Yeah. So I'll request Dr. S.M. Yadav sir to start with this session since we are already late, so we will not keep much time into it. I'll be sharing the resume of sir for your understanding and approach. So may I request Yadav sir to please start his session, sir?
Vipin, my slides are visible. Hello.
Yes, sir. Your slides are visible, sir.
Okay. So, good afternoon, participants. When I will be presenting, I think I do not know or I don't see the your comments or your slides at the same time. So your comments I cannot see. So if anything wants to ask in between, please unmute your mic and then you can ask to me. Okay. So I think this is your third lecture, third session since morning, and by this time probably you have got some idea about optimization. So can any participant unmute and reply what do you understand by optimization? Any one participant, please unmute
maximize or minimize the value of some function.
Okay, so we are saying maximization or minimization. Instead of function, we will say requirement. So proper word we can use is that maximization of our requirements or minimization of requirements. But why we need to do so, madam? Why we need to do that? Any other participant can also.
We need to do that because many times we want to maximize the profit, or we want to have the lowest cost for a given constrained environment.
Yeah. So important is what? Important is what? That you have some constraint, and under that constraint, either you want to maximize your requirement or you want to minimize your requirement. So when we say that or minimize your desired, you can say. So when we see it is not possible to find it out or to judge that how we can do that, and if you are doing that, whether the other parameters which are affecting our main objective function, right? So what will happen to that? Sometimes it will happen. Sometimes there is a constraint that a specific parameter you need to have in between certain range. You cannot take it at arbitrarily towards the infinite end or arbitrarily towards the minimization end. So you need that each and every parameter which affect the objective function have some range, and in that range you need to find it out what will be the maximum requirement or minimum requirement, and for that what will be the value of a specific variable, right, or specific parameter which is affecting objective function. So to all these things in engineering, not only in engineering, almost in all fields the optimization is used, and there are many methods by which optimization is carried out. Here optimization of reservoir operation to minimize irrigation deficiency using Jaya algorithm, that I am going to talk about in next 1 hour. Mostly this is the co-author Dr. Vijendra Kumar, who has got the PhD degree recently under my guidance, and this work which I am presenting, it is a part of his research work. Contents which we will be discussing today: introduction part, materials and methods, study area and data collection, development of mathematical model, results and discussion, and finally the conclusion derived for achieving a specific objective. If you want to cite article, this is the citation for this particular article. This paper has been published. Whatever I am discussing here in this 1 hour lecture, if anybody is interested to have details of it, they can have this paper from Hydro 2019 conference proceedings. This proceedings, I think it is Springer's proceedings, and it's available on the net. Not, you can ask Vipin Kumar sir, or you can write me. I can share the detailed paper with you. So you understand here, and after understanding how we have developed this particular optimization, or how we have solved this optimization problem, even after that, if you have any doubt, you can refer this paper and you can work on it, or you can understand it clearly. Some time back, maybe in the first week of July, there was a headline in Divya Bhaskar that in the month of July, water level in Ukai Dam was 319 feet, and the rule level is 321 feet. This we are talking of July, because June, July, August, and September we have monsoon, or we have rains for these four months, and rule level, I hope you understand that the level, predetermined level by government of Gujarat or by dam authority, till that level the water can be filled in a dam. So in case of Ukai Dam reservoir, the July month's water level was 321 feet, and in the month of July itself the water level reached to 319 feet. And I know that this specific article, when it is published, after that the dam authority was forced to release water, right, 1 lakh cusecs, 2 lakh cusecs, etc., to maintain the rule level of 321 feet. Why I am showing this? The reason is that we are talking about optimization. What's the title? We need to minimize irrigation deficiencies. So if you want to minimize irrigation deficiency, what is required? There should be enough water in a dam. So one side we are releasing water, we are maintaining the rule level of 321. Other side, you have to minimize irrigation deficiency. The irrigation deficiency can be minimized only if there is a water in the reservoir. At the same time, we are talking that we can water more than 321 feet is I think some participants' mic is not mute. Hello, somebody's mic.
Participants are requested please not to unmute yourself unless you have to ask some question. Sir, you may unmute yourself, sir, please. Sir, you are not audible, sir. Sir.
Hello.
Yes, sir. Now you are audible, sir.
So up till now, whatever I have discussed was whether I was audible or not.
Sir, after that you were not audible when I muted everyone. But before that you were audible, sir.
Acha. So this slide was okay that I was explaining. Was this slide okay?
Yes, sir.
Okay. So in 319, that is 2020, the rule level was 319. But you will see that in case of year 2011, in the year 2013 and in the year 2017, this level was 306 feet. Just imagine the water level in 2011, 2013 and 2017 was 306 feet, while in 2020 it is 319. Okay, so what happens due to this? If in the month of July the water level is less and if there is no rain, which happened successively for 3 years, right? That was I think 15, 16, 17, right? 15, 16, 17, 3 successive years. They were almost drought years, we can say, or there was less rainfall, and the water available in the dam was less, or water was not available up to the requirement. So what will happen due to this? If the water available in the dam is less, so from irrigation point of view, what will happen? Can we have enough water for irrigation purpose, for the purpose of irrigation? There is insufficient water. Vipin sir, have you muted all of them? Can they unmute themselves? Praniti Mishra, are you there? Praniti.
Yes, sir, they can unmute themselves.
Yes, sir.
So tell me, my question here is that the water stored in the dam is less, okay, while there is consistent irrigation demand, okay. So because of this, such year comes in case when there is less storage of water in the dam, right? Can the irrigation demand be satisfied or not?
Sir, repeat again, sir. Question. Sorry, I'm not getting properly.
I will repeat. Pranti, I repeated twice. Again, I repeat. If there is less water in the dam, right?
Yes.
And irrigation demand is consistent. That is not going to change. Okay.
Sir.
So if there is less water in a dam and the demand is there, what will happen? Can you able to satisfy irrigation demand 100%?
I think no, sir.
Right. So that's why the title of this particular topic is optimizing irrigation deficiencies, right? So first of all, you understand what I am trying to explain to you. It's important. What is actual optimization? Optimization is to minimize irrigation deficiencies. So point number one is here, why we need to minimize irrigation deficiency. The reason is that why we need to minimize irrigation efficiency, as you have seen in 2011, 13 and 17, the level of water was 306 feet, right? While in 2020, it is 321 feet. Let's see of other years. So these are the water level and rule level for Ukai Reservoir in the month of July. And you will find that the water level which is shown as blue line, almost except 2020, the water level was much below that of the rule level. That means maybe after there may be a successive rainfall in July, August and September month, and dam might have gone full. But if that is not the case, then what will happen? Every year your irrigation demand is fixed, or you may say that year by year the irrigation demand may increase also, depending upon what type of crop farmer grows. So depending upon that, the irrigation demand may increase, while the storage purely depends upon your rainfall. And if there is enough water in the reservoir, then you can supply water for irrigation. If you supply water is equivalent to demand, then what you can say about the irrigation deficiency, minimum or maximum? If in the reservoir the water is available to satisfy irrigation demand, all irrigation demand. So what will you say, whether the irrigation requirement is deficient or satisfied? Samdhan Deshmukh.
Satisfied, sir.
Yes, sir. If it is, hello.
Yeah,
Am I audible, sir? Yeah. Yes, sir. If it is there, then it will be satisfied. Water level is there, it will be satisfied.
Oh, that's wonderful. That's wonderful. Means if there is a water in the dam, then you can satisfy the demand. If the available water is less, what will happen? What will happen? There won't be the water to supply for the irrigation purpose, right? So why we need to optimize? Why we need to do optimization? This is the reason because of which we wanted to do optimization. If you will see the graph, you will find this is for the last 10 years or 12 years. You will find that 10-year period, there is a average storage. The blue line shows average storage and the other line shows the average demand, right, over the period of 12 months. And for the study period which we have considered, you will find that the average demand is less than that of the average storage, right? But here I wrote average demand. Here I have not written average irrigation requirement, right? That demand includes everything. So if my demand increases or demand is more than that of the average storage, what will happen? There will be deficiency in the irrigation water requirement, right? So in this study, in this research, we tried to minimize the irrigation deficiency for Ukai Reservoir. So you know what are reservoirs? So reservoirs are the most important component of water resources system. A reservoir is formed when a dam is built across a river. The main function of reservoir is to regulate natural flow and store surplus water. Water is either stored in the reservoir or supplied from the storage depending on the magnitude of natural inflow and demand at a certain time, right? A reservoir offers a water head that can be used to generate hydropower also. Once the reservoir systems such as dams, hydroelectric plants and networks of irrigation and canals are created, the advantages that can be achieved are largely dependent on how these reservoirs are managed. The effective use of water resources need not only prudent design but also good post-construction management. When we say that post-construction management, right? When we say that post-construction management, and how these post-construction management is significant or important, I think that those who are from South Gujarat or those who are from Surat, they very well know that what is the significance of post-construction management of dam. If anyone is from South Gujarat or from Surat, please unmute yourself and tell me what happened. I'm talking from water resources or hydrology point of view in 2006 in Surat. What happened in 2006 because of Ukai Reservoir? In 2006. Anyone is from Surat or South Gujarat? Exact date is 8/8/2006. 8 August 2006. Any participant from the South Gujarat or any participant from Surat? Please reply. No one? Okay. If no one is there, fine. The post-construction management is very much required, as in 2006 there was high inflow in Ukai Reservoir and more than 10 lakh cubic of water has been released by dam authority and 90% of Surat was underwater. So this is the example of what I mean by post-construction management. When we talk of reservoir operation, the reservoir operation policies are developed to enable the operator to take appropriate decision. The reservoir operation policy indicates the amount of water to be released based on the state of the reservoir, demands and the likely inflow into the reservoir. Why there is a rule level? The rule level is to manage the inflow in succeeding months. Suppose in the month of July, I fill the dam full and there is rainfall in the month of August, September and October. So where that inflow water will go if I have not decided the rule level? So 354 is the FRL of reservoir, Ukai Reservoir, and in July we fill it up to 321. So dam is remain empty between 354 and 321 for the months of August, September and October, right? So that is nothing but that is what reservoir operation policy. Why it's made? It's made depending upon the state of reservoir, likely demands and likely inflow into the reservoir. So 321 is the month of July. We are not filling up to 354 feet. The reason is that if you will fill it up to 354, the reservoir will be full. And in the next month, succeeding month, even immediately after July or August or September, if there is an inflow, right, it will be very difficult for water to store and nothing there to open the gate and release the water. The carrying capacity of river on the downstream side is only 3 lakh cubic. If you release more water than that, what will happen? It will start flooding the adjoining areas. The releases from a single purpose reservoir can be done with the objective of maximizing benefits. While the multi-purpose reservoirs, there is a need to optimally allocate the release among purposes. So, Ukai Reservoir is multi-purpose reservoir. And in case of Ukai Reservoir, from irrigation, the water is supplied for generation of hydropower, drinking purpose for Surat city, and industrial purpose for Hazira area. So Ukai is multi-purpose reservoirs, and in case of multi-purpose reservoirs, the demand is also different. As per Government of India norms, the irrigation water for drinking water be given highest priority, right? And then the irrigation water comes, then hydropower and then industrial demand. Right. So Our purpose is to minimize irrigation deficiencies depending upon the varying storage over the last 10-year period for Ukai Reservoir. So this is the hydroelectric dam. How is it operated? How the power is generated? It is shown in that. This is very popular. The operation of reservoir constitutes a very significant aspect of water resources planning and management. The operator must provide comprehensive instruction once a reservoir is created, enabling suitable management choices to be taken. In the reservoir's operating strategy, the quantity of water should be calculated according to the condition of the reservoir, level of requirements, and data on potential reservoir inflows. So, reservoir operation is a very, very tricky, what we can say, operation. Operating a reservoir is very tricky, and due to climate change, you may be observing that it is becoming more crucial worldwide. Why? Because there is a short duration intense rainfall in the catchment area of river results into rushing flows in the reservoir. And if your reservoir is not having cushion to store this excess water, what will happen? You have to open the gates, and the moment you open the gates and release water more than that of the carrying capacity of the reservoir, it will result into flooding of downstream areas. And this is happening all over the world where there is a reservoir downstream of it. As I said, due to short duration, high intense rainfall, the flooding is occurring in the downstream areas of the reservoir. So there are a variety of disputes occurring between demands for various reasons when operating a reservoir for more than one purpose, such as space, time, and discharge conflicts. In accordance with a set of rules or guidelines for water storage and release, a reservoir is run according to its purpose. Decisions on releases are produced in compliance with the demands in various periods. So we cannot operate reservoirs arbitrarily, right? Sometimes if you get chance to talk to any dam authority or any engineer who is managing water into the reservoir, please ask him that sometimes they come across such a situations that creates unbearable pressure on them. For example, in 2006, that is 8 August 2006, those 3 days, 8, 9 and 10, 7, 8, 9 actually, 7, 8, 9, the high dramas were going on in the collector's office, where the collectors, dam authority, the executive engineer or the dam authority superintending engineers who are responsible for operation of a dam, they wanted to release for any means because there are high inflows. Why the collector may be denying or refusing, no, you don't release this much of water because we have no time to shift the people from low-lying areas into the high areas, right? And that creates a pressure on the engineers who are operating dam because they are knowing that if they will not release the water, there are chances that the dam may over toppled, and if dam over topples, what happens? That is the example of 1979 Machu Dam to failure, right, where more than 25,000 people died and entire Morbi was washed away. If anyone is interested in reading this disaster, there is a book written by Utpal Sandesara and Tom Wooten named "No One Had Tongue to Speak." No one had tongue to speak. This is the book which is written by Utpal Sandesara and Tom Wooten on Machu Morbi Dam failure 2 in 1979. Okay, so we know that India has 3 seasons and mostly we have to depend on the storage of dam during our monsoon season. Our authority which forecast about the water is Indian Meteorological Department, and since last 10 years their performance has improved like anything. I'll not go through the optimization topic, just I will take the definition and various methods of optimization. I will not discuss, as I have been given 45 minutes to 1 hour. So I'll directly come to the problem which we have solved using the Jaya algorithm. However, just have a look at the definition of optimization, defined as the process of finding the condition that give the maximum or minimum value of a function where the function represents the effort required or the desired benefits, right? So what is the definition of optimization? The optimization is defined as the process of finding the condition that give the minimum or maximum value of a function where the function represents the effort required or the desired benefits. Design, construction, maintenance of engineering systems involve both at the managerial and the technological level, right? So goals of such decisions are either to maximize the required efforts or to minimize the required effort or maximize the desired benefit. So in nutshell, if I wanted to say what is optimization, then optimization can be defined as the process of finding the condition that give the minimum or maximum value of a function. If it is minimization, then we want to put minimum efforts, and if it is maximization, then we want to maximize the desired benefits, right? So engineering application of optimization, I know that you are from various expertise area of civil engineering. So any specialization you name, and there is application of optimization techniques. So this part I am not explaining you, right? Briefly I will explain the model building process. In case of model building process, it involves model building for optimization purpose. So development of optimization model can be divided into 5 major phases. Number 1, collection of data. Number 2, problem definition and formulation. Number 3, model development. Number 4, model validation and evaluation or performance. And number 5, model application and interpretation of results. So whenever you wanted to develop any model, right, you have to start with collection of data. Based on the data which you have collected, you have to define the problem, and based on that you develop your model. Then the model which is developed using this data, that is required to be calibrated and validated. Once it is calibrated and validated, it is ready for the application. Usually, as most of you are from faculty or teaching sites, what happens that some idea click into your mind that yes, we wanted to do this kind of work, and you assign work to your student, or you yourself start doing what we can say research work for any specific topic. And then what happens, the moment you start searching for the data, you find that some data which is required for your study are unavailable. And by that time you have already spent 2 semesters, 3 semesters, or your students half the semester is already over and half is remaining, and in that he has to complete his work. So always keep in mind, before giving or before deciding any topic for study, right, you should have whether the data required to analyze, whether the data required for the development of model are available or not. You cannot take it for granted, yes, we will get that data from this authority, we will get this data from this authority. No, till you are not sure that you will get data from specific authority, please do not start solving that problem, do not take up that problem, otherwise you will end up in mash after losing a considerable time period. However, for model development, optimization model development, these are 5 steps: collection of data, problem definition, model development, model validation and calibration, and model application and interpretation of the results, right? So this is all about the steps which I have described: data collection, problem definition, model development, model validation and evaluation, then modeling techniques. So various modeling techniques you are going to study during this STTP. There are n number of modeling techniques. Some of them I have listed over here. I will not read it. And then the classification, optimization classification, how the classification be done based on constraint, based on physical structure, based on nature of the equation, based on deterministic nature of the variables, depending upon the number of objective function, whether it's a single objective function or multiple objective function, and significance of optimization. So that will also be understood that real world problems you wanted to solve, right, where objective function is dependent upon one then more parameters, then how to which parameter is to be given how much important or which way it is to be done. So that signification of optimization is covered into it, right? Again, these are all about the various methods which are used by one or other people for solving of a problem, that is linear programming, non-linear dynamic programming, and traditional methods. They are used for the reservoir operations, and genetic algorithms are also used for the what we can say operation of reservoirs. This is the book, Application of Soft Computing Techniques in Civil Engineering. This book is authored by me, and as you are a participant of this STTP on soft computing techniques, I felt that let me share the detail of this with you, so that any one of you are interested maybe in environmental engineering, then these are all case studies. These are not the theoretical, what you can say, the theoretical basis of the soft computing techniques, but these are all application problems. For example, chapter 1, in which environmental engineering, municipal solid waste management, analytical hierarchy process is used. The second is the in case of construction project performance, the analytical hierarchy process is used. Then the third one is again environmental engineering, that pipe condition assessment, fuzzy rule based system is used. Again for water resources, spillway gate operations, fuzzy logic based operation system is used. Third one is fifth one is the groundwater quality modeling. So for that, geospatial and soft computing techniques is used. In case of groundwater quality analysis, that artificial neural network application has been given. In case of transportation engineering, application of artificial neural network and cellular automata, these two are given in this with the what we can say complete analysis that is been discussed in there. The water distribution network, how you can do analysis using genetic algorithm, that case study is discussed. And lastly, the linear programming case study of Curzon command area, that has been discussed in this book. This is published by Viva publication. So some of you are working in this area or wants to give topic to your student, this book can be a useful book, and where you can get the ready-made analysis of certain topics, certain issues, and from that you can get you may have a guideline to solve your own problems, right? So coming to our Jaya algorithm, we know that each and every soft computing techniques that is based on one or another fundamental requirements, right? And each technique has some sort of what you can say need. For example, that if you will take GA or if you will take PSO, then you need to tune algorithm specific parameters, and these algorithm specific parameters are not tuned. Till that, you will not be able to properly use the genetic algorithm or PSO or any optimization algorithm. So what is the advantage of Jaya algorithm? So to overcome the algorithms specific parameters are required to be tuned, right? To overcome Jaya algorithm have been newly developed algorithms which are free of these algorithm specific parameter. In view of Jaya's success in addressing various field and water resources issues, this paper applied to the problem of reservoir operation in order to minimize the irrigation deficiency. And the output of Jaya algorithm that is compared with two other optimization technique, that is in-feed optimization algorithm and PSO algorithm. So how is the Jaya algorithm? So as algorithm is developed by Venkata Rao in 2016, who was the speaker for inaugural session of today's program. The algorithm is based on the concept that the solution obtained for a given problem, we should move toward the best solution and must avoid. So these are the limitation of some of the developed algorithm, that they are not so refinedly tuned that it, instead of giving it in a best solution, sometimes get trapped into the worst solution and entire purpose of optimization get defeated. So by using Jaya algorithm, you can overcome this specific drawback of certain algorithms, and you can get the best solution using Jaya algorithm. The algorithm always tries to get closer to success and then tries to avoid failure. The flow chart of algorithm, this is the Jaya algorithm flow chart, in which you have to initialize selection of population, number of design variables, and number of termination criteria that you have to first decide. Then random generation of population, identify the best and worst solution, modify the best and worst solution as given by this mathematical formula. If the new observation or new solution is better than that of the old solution, then you have to accept, replace the previous one, and if the termination criteria is met, then terminate the program, otherwise repeat the procedure, right? So this is the algorithm, Jaya algorithm, based on which the solution can be taken up. Once the Jaya algorithm is applied, as I said, that model is required to be calibrated and validated. So between the observed values and the simulated values or optimized value, how will you find it out that whether your model is performing good or whether your model is performing poor? So for that, these statistical parameters are used in this analysis, that is root mean square error, mean absolute error, net shuffle coefficient, and their definitions are given how to compute it, right? Then performance evaluation indicators, that reliability and vulnerability index are used to find out the performance of the model. So statistical measures are used to find out the performance of model, that whether the model is performing better or not. While this performance indicator, this is the thing that uses how much is the reliable the results are. So that reliability index and vulnerability index, these two index are used for performance evaluation of evaluation indicators, right? These are statistical indicator, and these are what we can say performance evaluation indicator. Again, I say that root mean square error, mean absolute error, and net shuffle coefficient efficiency, they are statistical measures, while this reliability index and vulnerability index, they are the performance evaluation index, right? So Ukai study area, Ukai Dam is was constructed in 1972. It's on the Tapi River. The total length of Tapi River is 754 kilometer, and it's having a catchment area of 65,145 kilometers square. The Ukai Dam level, 8,000 at maximum water level, 8,480 million meter cube of water is stored, and full reservoir level is 7,414.29 million meter cube. Right, so this is a map of study area which shows the India in that Tapi Basin. Again, in Tapi Basin, it shows the Ukai Reservoir, and in Ukai Reservoir, the system of canals, because we are doing irrigation. So you will find that see the lower figure, right? There are 1, 2, and 3 figures. So see figure 3. You see it. There is a Ukai Dam on downstream side of Ukai Dam. That the Kakrapar Weir. There and from the Ukai Dam, two canals originates. That is Ukai left bank main canal, that is command area, and Kakrapar left bank main canal catchment area. So Ukai only one, that is Ukai left bank main canal is originated, and from Kakrapar Weir, 2 canals are originated. One on the Kakrapar left bank main canal, and another one is Kakrapar right bank main canal, right? So, and there is another one URMPC, that Ukai right bank main canal catchment, that is CCA, that is culturable command area. So these different colors which are shown on the downstream side of the Ukai Dam are the areas where the crops are grown or irrigation water is supplied, right, for growing of crops, right? So this is our study area, this area which is shown in the figure C, downstream side of the Ukai Dam, that is used for the what you can say irrigation purpose. So these are the silent features of the dam. What data we have collected for the optimization purpose. So Ukai Left Bank Division, Surat Irrigation Circle, monthly inflow from 1975 to 2016. Monthly evaporation rates, that is also for the same period. Monthly spillway data, monthly discharge data through the powerhouse, monthly discharge through Ukai Left Bank Main Canal, monthly levels of Ukai Reservoir, monthly storage capacity, irrigation demand for all culturable command area from 1980 to 2016, reservoir areas, that is 75 to 2016, domestic demand, industrial demand, and water quality demand, right? So with irrigation, how many other demands are competing? The demand for generation of power, the demand for domestic, that is drinking water, the demand for industrial water, and demand for water quality demands, right? So there should be minimum environmental flow into the river so that the water quality and flora and fauna prosper on the downstream side of the dam. So these data were collected and the mathematical model was developed. What was the objective of mathematical model? Minimize the sum of the square deviation for irrigation demands annually, right? So SQDV, that is sum of square deviation for irrigation demands annually. So what is that sum of square deviations for irrigation demand? So what is that? D is the demand, right? And IR, that is irrigation releases, right? That is SQDV, that is sum of square deviation of irrigation demands. T is equal to 1 to 12. So T is equal to 1 to 12 means for month 1 to month 12. D1T minus IR1T, D2T IR2T, and D3T IR3T, where T is equal to 1 to 12. Where what the D1 represents? D1, D2 and D3, the irrigation demands for the Ukai Left Bank Main Canal, Kakrapar Left Bank Main Canal, and Kakrapar and Ukai Right Bank Main Canal. So if you will see here in this picture, in this figure, right, this area KLBMC, ULBMC, and these two have taken combined. That is QRBMC and KRBMC. The water requirement, irrigation water requirement for this has been taken, demand for this has been taken combined. So that shows us D1, D2, D3, right? So D1, D2 and D3, that is the irrigation demands for Ukai Left Bank Main Canal, Kakrapar Left Bank Main Canal, and Kakrapar and Ukai Right Bank Main Canal for a period T is equal to 1 to 12. And IR1, IR2 and IR3 are the actual irrigation releases, right? So demand is one side, and actually depending upon the availability of water in the dam, the water is released into what we can say canals. So that irrigation demands are given as IR1, IR2 and IR3. So 1 represent Ukai Left Bank Main Canal, 2 represent Kakrapar Left Bank Main Canal, and 3 that is 3 demand and 3 releases, that represent combined Kakrapar and Ukai Left Bank Main Canal. So this I have wrote, these we have taken because we want to minimize the irrigation deficiency. So to minimize irrigation deficiency, we have chosen this particular objective function. Now, what are the constraints for demand? What are the constraints for irrigation releases? So that we have listed, and that according to that the constraints are same. First one is your continuity constraint, where the storage at the end of the day is equal to storage in the beginning of the day plus inflow minus outflow. This is the continuity equation for the storage, which explains you ST plus 1 means the storage at the end of the period is equal to storage in the beginning plus IT. IT is inflow minus releases for releases for one T is a release, that is releases to riverbed turbine, IR1, IR2, IR3 that is irrigation releases, ET that is evaporation, and OVF that is overflow. The water is overflowing. All this comes out to be ST1. So that is first constraint, constitutive constraint. Second constraint, storage constraint. What should be your value of ST? So ST, that is storage in the reservoir, need to be more than minimum storage and less than that of the maximum storage. So for that, what we have done, that we have got the data from 75 to 2015. So for that data period, we have find it out what is the minimum storage and what is the maximum storage, and that we have given as a constraint. Then evaporation constraint, we have used the equation for calculation of evaporation, and that evaporation we have calculated for all the years, and that we have subtracted that we have given as an input into continuity equation. Then canal carrying capacity, you cannot release water more than that of the carrying capacity of the canal. Therefore, the irrigation canal IR1, that is irrigation demands 1, that should be less than equal to the carrying capacity of the canal 1. Irrigation canal 2, that should be less than equal to the carrying capacity of canal 2, and irrigation requirement 3, that should be less than equal to the carrying capacity of what you can say canal 3. Then overflow constraint, so overflow constraint be given OVF equal to storage at the initial beginning, right, inflow, and all the what you can say the releases minus Smax, that is maximum storage. For example, if I want to explain this, right, as I have explained you in the beginning of this particular lecture, that the rule level of July was 321. So overflow, if the water in the month of June is more than that of the 321 rule level, what will happen? The overflow will start, because as maximum will be 321 rule level. So if the water in the reservoir is more than that, that is ST plus IT is more than that of the maximum storage allowable in the dam, then that will result into opening of the gate and the water is allowed to flow into as a overflow. Then irrigation demands, so that irrigation demand is minimum and maximum. The irrigation demand should be between the minimum requirement and maximum requirement. This data also we have find it out by collecting the actual amount of water supplied for a period of 1975 to 2015, and we find it out what is the minimum requirement and what is the maximum requirement for 3 catchment areas of Ukai, and that has been given as an what we can say irrigation demand constraint. Then environmental flow requirements, you know that there should be minimum flow in the river, right, which is to be maintained to maintain flora, fauna and aquatic life in the river. So for that purpose, environmental flow requirements, so that constraint was also given. So after giving all this constraint and coding in what you can say the MATLAB, for the Jaya algorithm along with PSO and IWO, these two another algorithm that has been run. See, the common control parameters such as number of iteration 25, 50, 75 and 100 and population size of 1 lakh were used to check the efficiency of algorithms over 10 separate runs. So 10 runs were done for this sample size for 1 lakh population. I am presenting this specific work. I have been given 1 hour time to present this work, but when we have done this work, when we have carried out this work, it took more than 1 year to run successfully this model. So sometimes it feels that the expert comes and he tried to explain you the certain what you can say algorithms or case study, and you feel that you will go I mean the expert have done some miracle and he got the results overnight. No, that is not possible. To run the algorithm itself is again a Herculean task, and you should understand what kind of error it gives. Sometimes the algorithm run also, but you should know that whether it has given the correct results or there is some error into it. So you need to know all these things when you are running, though the computers are there, though the MATLABs are there, though you can write the code, though you put the data and get the results, but you need to check the results also, that the results which you are getting out of your running of your algorithm, whether they are up to the mark or not. It has been observed that all algorithms perform better for population size of 50. Then there is another algorithm which are used, that is internal parameters for PSO, that is C1, and social parameters C2 were taken as 1.3 and 2.0, and inertia weight as taken as 1. These also, the PSO parameters also, we have referred the literature and we have checked it out, that what parameter values of conjugative parameter C1 and social parameter C2 are considered by the various researchers, and accordingly what they have suggested, these parameters were selected for our problem, because they have done for their problem that we cannot directly use it. Like here I wrote that 25, 50, 75, 100, 1 lakh population and 10 separate runs were done, and somebody tried for his problem the same Jaya algorithm uses, and he said that sir has told that population of size 50 was good for them and it will be good for me. No, that may not be the case. You may have to go for 25 or you may have to go for 75 to have better results. Similarly, for internal parameter for IWO, so for that also the seeds as minimum and as maximum were considered at 0 and 3. Non-linear modulus index alpha was taken as 2. Initial standard deviation and final standard deviation were taken as 0.6 and 0.001. So in this particular study, 3 algorithms were run. Number 1, Jaya algorithm, and to compare the results of Jaya algorithm with other algorithms, IWO, that is inverse inviscid width algorithm, and PSO, these 2 algorithms are run separately using the same data, the data which I have shown and the constraint which I have shown earlier. For that, the 3 algorithms were run, PSO were run, IWO were run, and Jaya algorithm were run. In case of Jaya algorithm, when the results are not up to the mark or the accuracy is not as we need, then there is a provision of penalty, and that penalty parameter you have to apply. That penalty parameter and that equation that has been shown over here in this specific slide. So after giving all the data and running algorithms, that is Jaya algorithm, PSO algorithm, and IWO algorithm, we got the various results like this. So for first run, you will see this is for first run, second run, third run, fourth run, fifth run, sixth run, seventh run, eighth run, ninth run, best solution, worst solution, and that of the mean solution. So this is the right hand side objective value, a mean square deviation of irrigation deficiency. So you will see in Jaya algorithm it is 0.4 times 0.2441, while in case of PSO it is 1.268, and while in case of IWO it is 0.144. So you can say that the Jaya algorithm has given the better results than that of the PSO and IWO algorithms. So that is written here in the, what you can say, the figure. And what happens as the number of iteration increases, whether the value of iteration objective function changes or error function changes or it remains constant. So that is convergence rate. It is called as convergence rate, and you will find that the convergence rate of Jaya algorithm was better compared to that of PSO. Of course, PSO and Jaya almost same, but IWO you find that it has converged late, right? So this convergence rate is also an important parameter when you are running, what you can say, any algorithms for optimization purpose, and it should be as minimum as possible, then it will give you the good results. Then the various statistical efficiency parameters were compared for a Jaya algorithm. You will find that NSE is 1, RMSE is almost near 0, MA is almost near 0, while PSO and IWO, the RMSE and MAE values are considerable compared to that of the Jaya algorithm. Right, the performance evaluation measures, that reliability index you will find for Jaya it is 99.99, PSO it is 99.93, IWO it is 99.96, while vulnerability index, that is minimum in case of Jaya algorithm than that of PSO and IWO algorithm. So in the current research to minimize irrigation deficiencies, optimal reservoir operation was developed. This has been implemented over the Ukai reservoir. The algorithm was found to be performing better compared to an inviscid weed organisms, or that is optimization, right? Rest I have already explained you that this gives you the better results. These are the training and program and workshop which I conduct, that is on storm drain design, water supply network design, sewer network design, application of subcomputing techniques, flood modeling for 1D and 2D, right? Water conservation practices, hydraulic structure design, long distance pipeline, and flood mitigation measures. Any of you are interested in taking joint work, collaborative work, either of a design or hosting a workshop or training program at your institute, you are most welcome. I hope I have completed in time. If some time is there, then I ask Vipin sir to take up one or two questions on this.
Thank you, sir.
Yeah.
I hope the session has been very elaborate and simplified, and it has addressed a number of issues which are of practical relevance to all of us. Now, sir, there are some questions. I'll just read out one by one.
Yeah.
So, first question is, excessive water can also be managed by canal distribution approximation.
This is asked by Vijay. Vijay, yes. You have seen that when we have done the programming, there was a constraint, canal constraint. So as you are saying, excessive water can be managed. No, it cannot be managed, because your canal have also carrying capacity. You cannot supply. In case of excessive water, what you wanted to do, you want to divert. What I understand by Vijay's question, that he want to divert excessive water into the canal. But the canal itself has a limitation of carrying capacity. So only thing, in case of excess water, either is enough storage available, right? Enough ocean available in the reservoir for the purpose of storage, then you can store there, or otherwise you have to release the water. And sometimes, as you have asked, that it happens that to safeguard the dam, the releases are so high that it inundates the downstream area, or it results into the flooding of the downstream area.
Okay, sir. Thank you.
So next question is, how the objective function was formulated in the case study?
I think this has been asked by Matthew. Actually, Matthew, the answer of this question I have already given, that when you are trying to take up some problem, for example, we have studied the Ukai Reservoir, and in Ukai Reservoir we found that the farmers of Ukai Reservoir, or the catchment area of Ukai, they are starving with water, right? As we have seen in 2015, 16 and 17, there are 3 successive drought years, and the water level was at the minimum level. Hence, they were not, the water was not supplied in certain catchment area of Ukai where they can do the crop production, right? So when you want to take up the study, you have to find it out what is the problem of that problem that you wanted to address. So we want to address the problem how, with the storage of last 15 years data, we can manage the irrigation water. So we have optimized, right, the releases in the canal, keeping in mind what will be the storage in the reservoir. So Matthew, that comes from what is your problem, what you wanted to solve, and to solve or to achieve that, the objective function is framed. So in our case, we wanted to achieve that, how we can effectively supply water to the farmers of Ukai catchment area, and therefore we have undertaken this particular problem, collected the data, analyzed, and find it out that this can be the optimum supply of water for all 3 areas which I have mentioned in presentation.
So Vijay also asked whether practical demo is covered. What do you mean by that, Vijay?
Probably he wants that how the MATLAB program has been run and coding has been done, right? So I think Vijay, that is not possible in to cover over here, right?
Yeah, no
so
problem.
For that, I think as I said, that 10 runs which we did for this specific problem, it took around 6 to 9 months, right? If MATLAB is there and I can run that code which we have developed, so that may take few minutes to solve the problem, but that will not demonstrate the how the problem can be solved. So the requirement for demo is you must learn first algorithms. Second, you must learn the language in which you wanted to do coding. For example, you wanted to do coding in MATLAB, so you have to learn the that specific language, and then afterwards you start writing the program. The program is the flowchart which I have shown you for Jaya algorithm. So for that you have to do coding for that particular flowchart, and then you can go on adding the data, go on adding constraint and in any software.
Okay, sir. Thank you, sir. Thanks, sir.
If any other participant has got any other query, you can unmute and ask sir directly.
Sir, for particles from a PSO, how the parameters were considered for this particular problem?
That's what I have explained, madam. When I was explaining PSO, that we referred number of research papers and we have find it out the range, that which way the conjugative conjugative parameter and the social parameters are considered. And by trial and error in our program, right, we have find it out this value will be better for solving of this specific program. So there is no direct what you can say a rule that by this you can take this and you will get the answer. It depends upon your problem. You have to refer number of research papers which have used PSO and the parameters they have used for analysis of it. Anita is writing water scarcity not satisfied the demand. Means what? Didn't understand.
Yes, can you please explain what you wanted to ask? Yeah, Lakshmi ma'am, you have got something to say. Please unmute yourself and ask. Lakshmi ma'am. Is there any other question by any other participant? Please ask.
Yes, Rashmi, you want to ask something? You raise hand. Rashmi, you raise hand, or by mistake you did so.
Yeah, maybe, sir. So all the queries are answered, sir. Thank you so much. Yeah, Shiv Shankar, Mr. Shiv Shankar, please ask if you have any question. You can unmute yourself and ask.
Sir, sorry, sir, by mistake.
Sorry?
Sorry, sir, by mistake it is.
Okay, no problem. Okay, so on behalf, sir.
Yeah, please.
Sir, can we conclude now then? All right, so if there are no more questions, on behalf of all the participants and organizer, I would like to thank our eminent speaker today. It was a very enlightening session, and sir has simplified number of things with a number of case studies signifying the importance of the topic and how we can try to solve these practical issues using soft computing. So if anybody wants to contact sir, the detail is available and visible on the screen right now. Those who want to have some work and or want to take some guidance related to soft computing, particularly application in water resources engineering, then they can approach, sir.
Any field, sir, not only water resources. In case of
Yes,
computing technique application in any areas, if you have any doubt or any query, you can write me. I think I have given my email address also, or otherwise I will type here in chat. You can note it down and you can post me your query. I'll be happy to answer your query. So this is my email address which I have typed in chat.
Thank you so much, sir.